My official apologies. The tests are not marked yet, but they are looking good, if that's any consolation. So as soon as they're marked, of course, I'll post the marks on Moodle, and then you'll have them on Monday. So today, we're going to do chapter 8. It's really just one section on mortgages. And so for this section, we're just going to learn how do we fill in this amortization table, essentially. Okay. And so it's just going to be a table of your payments, how much of that payment is going towards the principal amount, right? And how much are you paying in interest, right? What's the remaining amount, right? The balance. So we're just going to talk about how do we fill in this amortization sheet or schedule. And oh, I should say, kind of low turnout for test 3. I have a bunch of blank test 3s. If there's any takers after class, I'll just put them here. So now you know. Okay. All right. We don't need that. In fact, we don't need it at all. I don't think you had to put my name on there. You used to have to put my name on there, but I think the instructions are old and the sheets are new. Anyways. Chapter 8. Mortgages. So mortgages, right, are going to be, so I've given you written assignment 3 because this is the only section that you haven't been tested on already that's going to be on the final, right? And so everything else you've seen in a test situation, right, except for mortgages. So that's why I want to have it on Monday so that I can mark it for Wednesday and have it back to you so you can use it to study from, right? And so then you'll have feedback at least on everything that's going to be on the final, right? So you know what's expected of you. Okay. So mortgages, we first have to define some things like what's an amortization schedule? An amortization schedule. And for this one, right, I gave you just the mortgages examples, just so you don't have to make this long table every time, right? We'll just fill it in as we go. Okay. So an amortization schedule is a schedule of payments. Schedule of payments with a breakdown of the principal amount, right? How much are you actually paying off of your loan? Okay. Breakdown, payments with a breakdown of the principal amount the interest amount and the remaining balance. It's possible that you've seen some sort of amortization schedule. If you're looking at mortgages, that's the most common situation. Then they show you an amortization schedule and show you, okay, well, your first payment, right, this much is going towards the principal to pay off your loan, and this much is going towards the interest, right, because we have to pay interest on these loans. So we're just going to run through some facts. Okay. Basically facts of how we set up this amortization schedule. Okay. So the first payment or the first line on this table is just going to be payment 0 and then the balance, so the original loan amount, right? So how much are you borrowing usually for this mortgage, right? So say you get a mortgage for $200,000, then that's the balance, and that's all you have in row 0. Okay. So fact number 1. the first payment number, will always be 0. With blanks across the first row. With blanks across the first row. Except the balance will be the face value of the loan, right? How much did you originally borrow? So the balance will be the face value of the loan. Fair enough. We need to know how much we started with in order to start chipping away at it. Second fact, the payment amount, right? If you're thinking about a mortgage, the payment amount doesn't change, right? It's going to be the same every month or every week or however often you're paying, right? And so the payment amount is going to be the same for all these payments, except for maybe the last one where we just square off everything, right? There might be a little bit less owing, a little bit more owing, right? But we just kind of square up and then we're done paying off our mortgage. Okay? So the payment amount, will be the same for every payment. Except the very last payment. Where we need to square everything off. So it could be a partial payment. Okay. So kind of making our way through each of these columns, right? Just the facts about all these columns. And so the interest, right? It's going to be your periodic interest rate. Usually you'll have to calculate I2, right? But it's going to be your periodic interest rate times the previous balance, right? So for our first payment, you're going to have your initial balance here. Your first amount of interest is going to be the amount of interest that you have to pay on the previous balance. Okay. So the interest amount will be the previous balance, times the periodic interest rate, I'll say usually we have to find I2. Because our interest is going to be compounding at some frequency, just like before, right? And our payments are going to be, we're going to be making payments at some payment frequency, right? And so we have to find I2 so that the compounding frequency and the payment frequency match again. Right? So fact number 4. The principal amount, right, that's going to be how much was your payment minus the interest, right? You have to pay off your interest first, and then whatever is left over from the payment that you made, that's going towards your principal. So that's actually what's going to chip away at the balance that you're owing. Right? So the principal amount will be the payment amount minus the interest amount. And we've already kind of mentioned it, right? But the balance then is going to be the previous balance minus whatever principal you paid off. And then you're going to slowly chip away at this balance. Right? So the balance will be the previous balance minus the principal amount. Minus the principal amount. So notice how there's kind of a domino effect, right? You really only need to know the balance. You have to know your payment amount, right? And you have to know your interest rate, right? Your periodic interest rate. But then you can take your previous balance, find the amount of interest, subtract that from the payment, and then you have your principal, and then you can find your new balance. And now you use your new balance to go to the next row, right? And then you work through it and through it and through it. Right, so it gets a little tedious, but it's pretty fun. So, but like I said, I like tedious. It means it's easy. So, one little hiccup is when we get to the last row, right? So the last row, that's when we're done paying off our mortgage, right? And so the balance has to be 0, right? So instead of starting from the previous balance, right, what we do is we start and say, well, we have to force the last balance to be 0. And then we work backwards that way, right? Because that means that the principal that we're paying off, right, the remainder that we have to pay is the amount of the previous balance, right? We still owe that much. Nothing ever happened. Ooh. I'm the okay. Seems to be recording. Okay, so I guess we'll see if the recording craps out. Sorry. Potty mouth. Kick me out. It says recording. We'll see. Anyways. Okay. Pretend like nothing ever happened. You'll never get those last 5 minutes back. All right, so what did we say? So to calculate the last row, set the balance to $0, right? That makes sense. We're done. Our balance should be 0. Calculate the interest. Oops. Calculate the interest on the previous balance. The principal little lag must be the amount of the previous balance. The final payment amount, right, will be the principal plus the interest. Final payment amount must be the principal plus the interest owing. Cool. Feel ready to tackle these? Okay. So usually the first thing I make you do is find the payment amount. But that's the same situation that we were just dealing with on the test, right? So if you're reading, say, written assignment 2, and I've stolen the exact same format as you'll see on the final, right? And so first calculate the payment amounts. I make you construct a partial amortization table. I'll talk a little bit more about that, right? And then fill it in on this page. And then what was the total amount of interest paid on this mortgage? So let's raise them up. Okay. So all kind of things that we've seen before, but not in this context. So let's do example 236. I'll go steal it. There. Could have sworn I put it in here somewhere. No. Okay. Oh, do you guys want to see something funny? So here's a scatter plot. Here's a scatter plot. Oh, it's lagging. It's a catter plot. Anyways. Everything's lagging. It's insane. It's not on my Google Drive. Nothing's working today. All right. I guess I have to make the table. Annoying. All right. So example 236. No, you know what? Just need to be a little bit more clever. Focus. Great, I did it. Aren't you guys impressed? Oh. Yeah, right? Wow. I'm glad you guys have done your evaluations already. Okay. What a mess. Okay, whatever. Fine. It doesn't like the page breaks. The imaginary page breaks. All right, here we go. Example 236. Little bitty here. Norm wants to purchase a home in West Kelowna for $308,000, don't we all? He intends to make a $100,000 down payment, with the remaining payments being made bi-weekly over a 25-year period at 4.75% compounded monthly. Okay. So far, this is all information that we're used to dealing with, right? We want to have a mortgage and we want to pay it off with these bi-weekly payments over a 25-year period, right? Construct a partial amortization schedule showing details of the first two payments, payments 324 and 325. Oh, come on. And the final two payments. Okay. So we'll deal with the first two rows, and then we'll talk about how do we get the 324th payment and the 325th payment. Okay. So here, 0, right? Start filling this in, the payment amount, is we're to get through this quickly, I guess. There you go, 208. So we want to find the payment amount first, right? And so need to find the payment amounts. So we can make a timeline if we want to. On the final, I'll only expect to see some calculator work, right? So you don't even have to show the timeline for this question because you've shown so many timelines before, but we can show that this is the same thing. So for 25 years, I think it was. And we're making bi-weekly payments. So we've got 26 payments for 25 years, 650, I'll just say BW, bi-weeklies. So we've got 1 bi-weekly payment, 2 bi-weekly payments, 649 bi-weekly payments. And it says, okay, well, we're making end of the month payments. I think it was. Is it? It's not clear, so it must be end. So we can make a little note here. It's at the end because it's not clear. Remember, the default is that it's going to be at the end. If it's at the beginning, if these payments are at the beginning, then I would have to make that very clear, right? Beginning of the bi-weeklies or whatever. Okay. So that means we have a payment here, a payment here, a payment here, and a payment here. How many payments per year do we have? We have 26, right? And what's the compoundings per year? Compounded monthly, 4.75% compounded monthly. 12. So these are not the same, so we have to find I2. Right? So first we find I1, so R1 is 0.0475, right? So I1 must be R1 over F1. Remember, our compoundings per year is the F1 and our payments per year is your F2. So this is the same I2 that we've been finding all along. And we need I2 later. Even if we're using our calculator to find the payment amounts, we'll still need I2 to calculate the amount of interest that we have to pay. Okay. So I2, 1 plus I1 to the power of F1 over F2 minus 1. Forgot this step. 0.047 divided by 12. 0.003958, repeating. 1 plus 0.003958, repeating. To the power of 12 over 26 minus 1. So plus 1 to the power of 12 divided by 26 minus 1. 0.00182498. We're going to use this a lot, so definitely store it somewhere. Store it in 1. Okay. We need to know what payment amount is going to pay off some present value of $208,000 because we were told the down payment amount, right? Usually I'll tell you, oh, he makes a 10% down payment And then you have to figure out what that is and subtract it from the overall amount. Now I've just said he makes a $100,000 down payment. So then it's easy to know what the present value is. So he's only paying off $208,000 with these payments. So we'll just use the calculator. You can do it by hand. You can find the PMT by hand if you want, but we'll just use the calculator. Interest per year, present value, payment amount, future value, payments per year. Oops, it's a Y. Compoundings per year, and beginning or end. Squeeze it in. So our N, we said we have 650 payments. So 650 payments. Our interest per year was 4.75. Our present value is 208,000. Our payment is the one we're trying to find. Our future value, when this is all paid off, is going to be 0. And we have 26 payments per year and compounding monthly, so 12, and we're at the end. So now we can use our calculator. Say 650 is the N, 4.75 is the interest per year, 208,000. That's going to be positive, right? Because he gets this loan amount. Right? He chooses to put it towards the mortgage. Right? And so that's the present value. I'll put in 0 for payment. Apparently you can just skip it because of course when you compute it, it'll just overwrite whatever's in there. 0 for the future value, and then payments per year. I have 26, enter. Compoundings per year, have 12, enter. Compute the payment. I get a payment of $546.730574. His biweekly payments. The negative just means that he has to make these payments. Right? He got some loan amount, now he has to pay it off. Biweekly payments are $546.73. So we can take this to our sheet, right? You have one in front of you, and I'll just list so the payments that we have to find. So payment 0 is always your first line, and then the first and second payments is what we're told to find. And then I'll do ... in one of the lines. We want to find 324 and 325. We need to know the previous balance. So we need to know the previous balance at line 323. I'll tell you that much right now. So 323, so that we can find 324 and 325. And then ... And then I want to find the final two payments. We know there's 650 payments, right? We just found that. And so the last payment here is 650, or the payment number, right? Not the payment amount, the payment number. And so the last two payments would be the 649th payment and the 650th payment, right? But just like in the first row, right, all we need is this previous balance. We know the payment amounts, because we just found them, right? And so same thing here, we need to know the balance at 648 at that payment. And then we can take that balance and figure out the rest of the rows, right? So we need to save room for 648. How do you think we're going to find this balance? If we said, okay, well, the balance after 650 payments had to be 0, right? That's when we're done. But this at 323 must be the future value after 323 payments, right? So you can just use your calculator to find the future value at 323, and that's going to be the balance after 323 payments. And then you have that, and now you can fill in 324, 325. Same thing for the last two payments. You can set your number of payments, N, to 648 and calculate the future value. And then you'll have the balance just like that. Fun, right? What? It's all in the calculator? Well, basically. So 546.73. Oh, nothing in row 1. Oops. Come on. So wherever I need a payment, I'm just going to put 546.73. 546.73. We found that, right? So we know it's going to be 546.73 all along here until the last payment. We don't know the last payment amount. Da-dum, da-da-dum. However you want to show it. If you just do 546.73 once and draw some sort of line or ditto marks or whatever you want to do, works for me. Okay. So, okay, let's deal with this first line. So we said that our interest, right, we have to figure out how much interest we have to pay on the 208,000. And so to find this interest, okay, to find the amount of interest on line 1, amount of interest on line 1, you take your previous balance times I2. Okay. So the very first balance that we had was 208,000 times I2, which was itty bitty. I'll do a recall one. Times 0.00182498 times 208,000. So I have to pay 379.595851 for first interest payment must be 379 and 60, right, with rounding. Okay, 379.60. So we made a payment of 546.73, right? But we also know that 379.60 of that has to go towards the interest, right? The rest is going to be the principal. So we have 546.73 minus 379.60. So the amount that we're paying off on the principal is 167 and 13 pennies. $546.73. So that's your payment amount, right? But $379.60 of that is paying off the interest. So we always have to pay off the interest first, and then whatever is left over of your payment goes towards your principal. Womp womp. So only $167.13 are going to get chopped away from that 208, but we have to update our balance, right? And so 208,000 minus $167.13, our new balance, 207,832.87. This is going to take forever. 25 years. So now we have our new balance, which again, so now we have to pay interest on the new balance. Right, a little bit less than before. So I just keep the new balance on my calculator and I multiply it by recall 1. And then that way, recall 1, right, is my periodic interest rate I2. So now I get $379.30. 30 cents less in interest. I did the 207,832.87 times the interest rate I2, which I've stored in 1. Okay. So the amount going towards the principal then should be 30 cents more than before. So 546.73. You'll want to be careful. I know I've been harping on you guys to keep all your decimal places, but now because we're dealing with money, right, at each step we have to round to 2 decimal places. So 546.73 minus 379.30. So now I'm paying 167.43. Step in the right direction at least. So now I take my 207,832.87 minus what I just got. So now I'm paying off, my new balance is 207,665.44. And so it goes. This very first one here, the 167.13. So that's going to be from, so you're okay calculating the amount of the interest? Yeah. So then your payment rate is 546.73. Yeah. But you have to pay off that 379.60 of interest. So of your payment, right, so from your end, you just make a payment to the bank. 546.73. They say, fine, but we need to take the interest amount of 379.60. So we subtract the 379.60 from the payment, and that gets you your principal amount. Cool. And then you subtract that principal amount from the balance. And then it just keeps going. Okay. So, yeah, any questions about that? We'll do a few more rows. 80% attitude. Like all math, 80% attitude. Yeah, of course. So, this just keeps going and going. Like I said, we need to know, so we need to show, I tell you to show rows 324 and 325. Right? Same thing on here, but I ask you to show the 121st and the 122nd payment. Doesn't matter, right? Regardless of which row I want to show, I need to know the balance on the previous row, right? Because we use that balance to figure out the amount of interest that we have to pay. And then from there, we'll know our principal amount, and then we can figure out our new balance. So, to fill in rows 324 and 325, we first need to know the balance on row 323. This is the same as the future value after 323 payments. Okay. This is the same as the future value after 323 payments. And this is where I would recommend just using your calculator. So we've got the interest per year, we've got the present value, we've got the payment amount. We know the payment amount now. So that's right, good, right? And the future value, the payments per year, and the compoundings per year, and whether we're at the beginning or the end. A lot of these entries are going to be the same as we had before, right, when we were calculating the payment amounts. Okay. So now our N has to be 323. And I'll just highlight that as a big change, right? We had 650 payments, but then we were trying to figure out, okay, in 25 years, what payments do we need to pay this off, right? Now we're trying to figure out what's the value of this loan after 323 payments. The interest per year is still 4.75, that's the same. The present value was still 208,000. Our payment amount, we know is negative, do I have it? 546.73. And so that's new. I'll just highlight it here. That's new to this calculation here. Future value is the one we're trying to find. All right. What's the value of this loan after I've made 323 payments of $546.73? Our payments per year are still going to be 26, and our compoundings per year is going to be 12, and we're still working at the end. So 323N. If you're brave, you wouldn't have to fill in any of these ones that stay the same, but I'm not that brave. I always just go back and fill them in again. Present value 546.73 negative for the payment. 0 for future value. Payments per year, compoundings per year, good to go. Compute future value. I find that the future value is 546.1137. So if we wanted to square up after 323 payments, that's how much we would have to pay, right? Which is the balance. Ooh. The balance at 323 payments is $134,546.1137. 0.11. So let's sneak that in here. Oof. So we're at 134, 546.11. These we don't know, and that's okay. Because what would you need to know to find the interest amount on line 323? You'd have to know the balance at 322. Right? But now we can take the 134, 546, oops, 134, 546.11 times, I stored it in 1, recall 1. And you should get an interest amount on line 324 of 245.54. It's my I2 that we found. It's the 0.00182498. So now we have to take 546.73 minus 245.54. Well, finally, we're paying off more on the principal than we are for interest. It's a nice feeling. More than half of your payment is going towards paying off for your mortgage than just maintaining interest. So now our new balance is going to be 134.546.11 minus the principal 301.19. So now we owe 134.244.92. You can find the interest on line 325. Right? Take the previous balance, multiply it by I2, so times recall 1. The amount of interest, $244.99. It's on sale. So our principal is going to be 546.73 minus 244.99. 301.74. And then our new balance, right, is going to be 134.244.92 minus 301.74. 133,943.18. Oh. Cool. If you think about, right, if you're checking these numbers, then the amount of interest that you're paying should always be decreasing, right? As you move down, 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 you should be paying less in interest, right? Because you've paid off more and more of your balance, right? And so this should be decreasing as well as the balance should be decreasing. But the amount that's going towards your principal should be increasing as you move down, right? Because you make that shift where you're paying off more and more towards the principal, right, as you're paying off more of your balance. So we do the same thing for the last two lines. And so we're gonna find, we need to find the balance at payment 648, right? Because I want to see 649 and 650, but that implies that you need to find the balance at 648. So we use that same calculation on your calculator that we did, but now we want the future value at the 648th payment. Okay. So for rows 649 and 650, we need the balance from row 648. This is the future value after 648 payments. So again, we've got N, the interest per year, the present value, the payment amount, the future value, the payments per year, the compoundings per year, beginning or end. So N, right, we want the future value at 648 payments. So 648, the interest per year doesn't change, 4.75. So again, I'll just highlight that this is the one that's changed. The present value is still 208,000. Your payment hasn't changed from your previous calculation. It's negative 546.73. Your future value is the one you want to find. You've got 26 payments per year and 12 compoundings per year, and you're at the end. So technically, all we have to change, right, is our N. Let's try it, 648 into N. And then we can jump straight to finding our future value if you want to. Like I said, I'm usually not that brave, but we can. Yeah. Our future value is negative 1,091. Now we're talking 0.185749. The balance owing after 648 payments is $1,091.19. I'd be so impatient. Just pay it off and get it over with. So we can fill that in. 1,091.19. So then we have to pay interest on that, right? 1,091.19 times recall 1, your I2. We are paying $1.99 in interest, and doesn't that feel good? We also don't have that much owing, so it makes sense. So $546.73 minus the $1.99 that the bank takes for their interest. Towards our principal, we're paying off $544.74. We can find that second to last balance. The last balance, remember, has to be 0. And so 1,091.19 minus 544.74. So we have a balance owing of $546.45. This is where we change gears, right? And we say, okay, well, we're down to our last payment here, right? We know the balance here has to be zero, right? There's no two ways around it, right? The bank is going to want you squared up. And so you can put zero here, but that also means that the amount of principal that you have to pay must be $546.45. So you put zero here, and then you transfer this balance to the amount of principal. Right? You have to pay that off. But you also have to pay interest on the $546.45. Right? So you're going to calculate the interest that you would have had to pay. And then you're going to add the interest plus the principal to get that last payment amount. Right? Because it's where you're going to square up your account. And so we have to have a balance of zero here. And we have to pay $546.45 for our principal. Otherwise, our balance wouldn't be zero. $546.45 times I2. We have to pay 0.997, so that's a whole dollar, right? $1 with proper rounding in interest. So our last payment must be $546.45 plus $1. So $547.45. Just highlighting that one's a little bit different, right? Because you had to work backwards from the principal plus the interest. That's your last payment. On the assignment and on the final, right, once you've made this amortization schedule, that's great. I ask you, what was the total amount of interest paid on the mortgage? Right. So then we're going to figure out, okay, well, we made 649 payments of $546.73, right? Plus this last one, $547.45. So we can figure out how much we paid, right, in total. And we know how much we were owing. So the difference between how much we paid and how much we owed, that's how much interest we paid. Right? So how much did Norm pay in interest? So you made 649 payments of, what was it, 546.73? Did I make that up? No. Plus one payment of 547.45. So the total paid is 649 times 546.73 plus 547.45. However you want to show this calculation is fine. I just wrote that way. Oops. 649 times 546.73. That's $354,800. 827.77 plus 547.45 plus 547.45, 355, 375.22. That's how much he paid out of pocket. So the interest paid is going to be the total paid minus original loan. Bless you. So that's going to be your 355, 375.22 minus 208,000 it's going to pay $147,375.22 in interest. Yikes. Not too fun. But that's how it works. Oh, cool. Let's get started on the next example. Okay. We'll calculate the payment amount and I2, and then if you want to stick around, then that's great. If not, you can probably fill in this table just going off of one example. Okay. So example 237. Let's see if I can. Oh, it took a picture of everything. Oh well. Carrie bought a $175,000 condo at Big White for 20% down. So 20% of that she paid down, right? And monthly payments for 15 years. Construct a loan repayment schedule detailing her first 3 payments and her last 3 payments. All right, keep that. You may assume a 5% rate of interest compounded semi-annually. And so let's just figure out, so she's making monthly payments. Again, because it's not clear that these are at the beginning of the month, they're going to be at the end. Right? And so again, we're working at the end of the month, and our payments per year, it was monthly, right? And monthly payments, and our compoundings per year, semi-annually. Nice, reasonable too. This is going to be your F1, and this is going to be your F2. R1 was 5%. So I1 must be R1 over F1, 0.05 divided by 2, 0.025. So calculating I2, because as you noticed, we use I2 a lot, right, in this table. And so I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.025 to the power of 2 over 12 minus 1. 1.025 to the power of 2 divided by 12 minus 1. 0.00412391.5. I'm going to store that in one. My go-to. So this is our periodic interest rate for all of our interest payments. So find payment amounts. So let's say, so she buys a condo for $175,000 and puts 20% down. Okay. So the down payment is 175,000 times, remind me, 20% down, so 0.20. 175,000 times 0.2. So she's already paid 35,000 of that 175. Okay. So the total balance owing that she has to pay off is 175,000 minus 35,000. $140,000. Okay. Because it's fun to fill in the payments, we found that the first balance must be 140,000. We know there's nothing else. There's no payment, there's no interest, there's no principal. So we need to find our payment amounts. So if we just go N interest per year, skipping the timeline, although you could very well do a timeline if you want to, the present value, the payment amount, the future value, the payments per year, compoundings per year, and beginning or end. N is the number of payments, and she's making monthly payments for 15 years. 12 times 15 is 180. So N is 180. 12 times 15 is 180. Oops. Interest per year was 5. The present value, so the loan amount that we're paying off, is 140,000. Our payment is what we're trying to find. Our future value, once it's all paid off, has to be 0. And we're making monthly payments and compounding semi-annually, and payments are at the end. Payments could very well be at the beginning of each month, but all that would change is the mode on your calculator, right? Or if you're calculating these things by hand, you would have to calculate an annuity due or a payment amount if you have the present value due. Easier on your calculator though. So we've got 180 for N, 5 for the interest per year, 140,000 for the present value, 0 for the payment for now, 0 for the future value. Compoundings, payments per year is 12, enter. Compoundings is 2, enter. And now I can compute the payment amount. Payments are going to be negative 1,103.373329. Her monthly payments are $1,103.37. So we can fill that in. First payment, second payment. Oh, her first 3 payments, fun. 1103.37. Oops. And that's going to be the same for all of these. And then the last 3 payments. So we know that there's 180 payments in total, right? I think that's what we said. So we know starting from the bottom, now we're here, 180, 179, 178. That would give us our last 3 payments, but we need 177 in order to find 178. So we need 177 as well. But here we've just got ... We don't need any payments in between because I didn't ask for any. Construct a loan repayment schedule detailing her first 3 payments and her last 3 payments. So that's what we're doing. Okay. So let's figure out. So our interest for the first line, 140,000 times, recall 1, that's your I2, right? Or wherever you stored your I2. The amount of interest that you're paying should be 577 and 35 pennies. So you're paying 1103.37, but 577.35 of that is going towards the interest, which means $526.02 are paying off the principal balance. So now you owe 140,000 minus 526.02. So now you owe 139,473.98. Interest owing on that times recall 1, 575.18, right, with rounding. Question? So we have to use the I2 that we found. Okay, so you store it in 1 or wherever you've stored it, and then you take the balance amount from the previous row. So first one, 140,000 times I2, okay. And that should get you 577.35. And then you just keep taking the previous balance times I2, feeding it in. Where do you see? Whereabouts? There? Good? Okay. Ooh. So. I'll let you guys fill in the rest there. Let's deal with 177. I'll post the solutions later for all 3 of these examples, but we'll probably only have time to work through the first 2. Okay? But I promise I'll post the solutions to all 3. Okay, so balance owing at 177. So need the balance owing at line 177. And we need the interest per year, the present value, the payment amount, the future value, the payments per year, the compoundings per year, and the beginning or the end. And has to be 177 now. And so that's changed from before. The interest per year stays the same, 5. The present value, you're still paying off 140,000, but now you know your payment amounts, and they have to be negative, right? Because you're making these payments, 1103.37. If you made both of them positive, what would you be telling the calculator you're doing? You'd be telling the calculator that, okay, first I got 140,000 as a loan, but then I'm also getting 1103.37 every month for 177 months. How much would I have owing? That's going to be huge, right? If you keep borrowing, if you drop this and you didn't have that negative there, right, that would make a huge difference in how much you have owing, because you're not chipping away at what you have owing. You're actually adding every month 1,100 to what you're owing, right? So that's why those pluses and minuses on your calculator make a huge difference. So we need our future value. That's what we're here for. Our payments per year are still 12, and our compoundings per year is still 2, and we're at the end. So 177 for n. Do we dare do it? No, we can't. I don't have the payment stored in there. 5, interest per year. I'll just start over. Present value of 140,000. 1103.37 negative. It's my payment amount. I'll put 0 in for future value now, and then payments per year is 12. Just checking. Compoundings per year is 2. Great. Compute future value. The total owing after 177 payments is, so the future value is negative 3,283.870268. Balance on line 177 is $3,283.87. 328387. So we can put that as our balance here. 328387. We know the payment at 178 is 1103.37, and at 179, 1103.37. We don't know the payment at 180, right? Because that's the one where we have to square up. Okay. But we can find the interest owing on $3,283.87, right? So take $3,283.87 times I2, I have it in recall 1, I have to pay $13.54 in interest. Subtract that from my payment, 1103.37 minus 1354. So 1,089.83 goes towards my principal. It's a nice chunk. So from 328 or 3283, sorry, 0.87 minus that previous answer. Now I owe $2,194.04. I have to pay interest on that. So times recall 1. $905. 1103.37. The bank takes their $905. I get to pay off $1,094 2194.04 minus 1,094.32. I owe 1,099.72. I have a feeling I messed up. Is that what everyone's getting? Okay, last row, right? We know our balance has to be 0. And we know that we have to pay 1,099.72, right? And so that has to be our principal amount. So 1,099.72. That's what we're forced to pay in principal. But we also have to pay interest on that, right? So times, recall one, $4.54 in interest, making our total payment $454 plus 1,099.72, $1,104.26. Notice that this one is slightly different. From there, you can find how much interest was paid, just figuring out total amount paid minus total amount borrowed. There you have it, folks. So you have everything you need to do your written assignment 3. Have a great weekend. See you guys on Monday. Oh, did anyone not get the assignment? Got a lot of them. Okay.